Yes, hello. My name is Martin. I'm an associate professor at NTNU, and I will talk to you about this small project we've had in the AQUAEXCEL project, where we had looked at new methods for post-processing biotelemetry data in aquaculture. This is work we've done together with the University of South Bohemia. First, the knowledge needs of this work is tied into these devices here. These are telemetry tags. They're used to collect data from individual animals in the cages. This can tell us something about the individual behavior of the animals. It's a useful tool. We can use it to get time series data like this that describe how the fish behave over time. In this case, activity during a delousing procedure. You can also use the data from these individual tags to get statistics like this. In this case, I made a distribution of the depth of the animals based on data series from telemetry tags. These are both useful tools, but we are thinking in this project, what if we use new methods to gain more insight? Because getting these kind of data with the telemetry tags is quite hard work, it's expensive. Why not try to use established methods to get more information out of these tags? I will present to you the two solutions that we have explored, which kind of gives an image of what the thought is here. So the first solution is based on the use of artificial intelligence and those kind of methods. So in this case, we had a time series of individual positions from individual fish in the cages. So you had a time series of positions. We subjected these to PCA and statistics, so principal component analysis, to try to identify typical patterns in the data, like circular swimming as illustrated here, which is an interesting property related to the behavior of the fish. The next step was then to use deep learning and clustering to find out how often do the fish display these patterns. And this gave us the frequency, how often the fish do them. And this tells us more about the individual behavior of the fish than analyzing the time series as one big chunk of data. The other solution we have explored is more related to the signal properties of the data. This is a long time series of acceleration data and depth data measured in a cage. And in this case, we wanted to explore what if we just look at the signal as a signal, a digital signal, and look at those properties and see if this can tell us something. So then we use the concept of entropy, which is basically a measurement of how much information varies over time. And this allowed us to identify clear peaks in the signal entropy of the data that coincided with delousing events. So this told us that it is possible to gain early warning systems without even having to care about the data values you're measuring, just looking at the variations in the signals. So these are but two examples of what we think is possible by using well-established methods that are available and out there. The target market is basically, first of all, the providers of these telemetry tags. So you have some examples of telemetry tags here. The providers of these tools could benefit from adopting new methods to process their data and offering this as a part of their software suites to present and process the data from their tags. This could give better insight into the data. And it could also then help us as scientists and academics to gain more knowledge about the fish in the aquaculture, which is exactly why we're here. So the reason why we're researching technology for measuring the fish in the cages is to be able to see, can we find out how management operations and the environment affect the behavior and the physiology of the fish? Can we measure this and thereby gain a deeper insight into how the fish are behaving and how their states are during the production? So, that's it.